Good evening. Myself, Yeswanth Raj. What is machine learning? Think of an example. You're a human being and you learn things from your past experiences and from some other person's guidance. In the same way, the machine could learn the things from the past data that we provide to train. And from the training that we provide, it will try to learn it somehow to the bits you can see in the background image like 0 and 1s in a binary system, and it somehow predicts the output when we give a kind of input to predict the output based on this past data. This is what generally machine learning is. And why do we use machine learning? Well, we use machine learning in many fields to reduce the time it takes for the things we do, like predicting the things like medical diagnosis, image processing, prediction, classification, learning association, regression, and mostly you use Google Assistant and Amazon Alexa every day. And those use these machine learning algorithms to answer your question appropriately. So it makes our life easier. This is where the machine learning emerged. And think of another example. You want to buy a house and you have a data that's multiples of doubles like 500 square feet, 1000 square feet, 1500 square feet, and this is the data you have, and you want to buy a house of 750 square feet. How? Either you have to analyze the data and you have to take an average and do the computations to find this price, or you just use this machine learning algorithm to predict for you. One is better, right? So we use this machine learning prediction, we train this data, or we make the machine learn by giving the input and past data, like what for what a square feet the price would be this much, for 500 square feet the price would be $100. Assume that it won't be $100, it's more than that. So in that way, if you input the data of $750 or 750 square feet, it will give the outputs in somewhere between 150 or 160. So that's how it works, and this is where machine learning actually helps you. Going deeper, basically this is the example I've mentioned earlier, like humans learn everything from experiences, whereas machine learn from its past data, which aids this machine learning algorithms. Here down this line, I have given a diagram and it elucidates everything. Like we give an input data and it goes through this machine learning algorithm and it builds logical models on itself, computing everything that you provide as an input. And when you input a novel data or new data after training and testing, it will predict and give some output. And this is what how it works. And further, in the machine learning, it is classified into 3 parts: supervised learning, unsupervised learning, and reinforced learning. First, we'll learn about supervised learning. What is supervised learning? As we all know, or as we can see, supervised is nothing but it works under some supervision, someone's supervision. Here, the supervisor are nothing but humans, because they are the machines and they ought to be supervised by a human. And they work and they learn, and we train, we test them. Everything, is gonna get things done under a human supervision. In this learning model predicts the output for providing sample data, or put it this way, quoted labeled data. Because think this or remember this labeled data meaning, I'll explain it afterwards when it comes to unsupervised data. And this is the main difference between unsupervised and supervised learning. And take off an example, like student learn concepts from teachers under his supervision. This is what a supervised learning is. And applications are plethora of them. Like I can't even write all of them, and there is no space as well. So I mentioned a few of them, like spam filtering, price prediction, weather prediction. Basically, this supervised learning is furthermore classified into 2 parts: classification and regression. What is classification? So if you give a data as an input and you want the data to get output as, to print the output as yes or no, true or false, or is it a spam mail or not spam mail, then it is the classification. It draws a line between the data and it separates the data into two parts. Like, as you can see, the cross marks are indicated as zeros, think of as zeros, and the circles are as ones. And if you give a data of tumor size with respect to the age, and it draws a line and it separates the data and it predicts the output. Like if you give an input of this, as you can see the pink dot, it classifies automatically and it puts into the uh, zero ones, and it predicts that there is no this person has no cancer. So this is how it works, and it mostly used for yes or no, like uh, whether tomorrow is going to be sunny or kind of rainy, or this mail is a spam or not spam. Even though it misclassifies sometimes, based on these keywords, but mostly it classifies accordingly and it does its job correctly. Mostly we use for fraud detection, like giving the input as some keywords like offers, special offers, and we'll train the machine, and whenever it reads this message and it finds words like these offers and everything, it automatically throws it into the spam folder. That is the reason why, even though when sometimes some important mails gets thrown away into this machine, and they ought to be trained even further again and again over again, because there are fraudsters outside and they use different techniques to deceive these machine learning algorithms. And this classification is furthermore classified into four types: binary classification, binomial, multiclass, and multi-label. Binary classification. The example I mentioned earlier was the example of binary classification. So I don't have to further elucidate it since I explained everything, like zeros and ones. And when it comes to binomial classification, think of this way. You want to predict the data, whether think of an example like you've given a data like cats and dogs to the image processing, to the machine learning algorithm, and you want to predict a new photo whether it's a dog or a cat. Then instead of binary, you use this and it predicts like it is a cat or a dog. So this way it works. It can be binary. You can convert this data like cats as one and dogs as zero, but mostly due to the convention, it is named as binomial classification when you use this names instead of zeros and ones to break the perfect output. As I said earlier, it is akin to binary classification. Akin is nothing but similar to binary classification. Multi-class classifications. When you have more than three, when you want an output with more than three classified data, like as you can see on the screen, like orange, green, and blue, then this is the one. As it classifies the data into 0, 1, 2, like take off an example of this cancer. When you want to predict the output as severe cancer, benign cancer, or cancer somewhere stands in middle of both of them, then it would work efficiently and it gives the output separated into three different classes, three or more different classes, of course. Multi-labeled. As I said, label. If you want to get the output in in a multi-labeled fashion, like as you can see the Harry Potter movie picture on the screen, it gives the output horror as a 0.02%, 0.02% romance, and 99.96 adventure documents is 0.0%. And you take this as an example when you want to predict a movie, whether it's a rom-com, adventure, sci-fi kind of documentary, then it works well. It processes total data or total description of the movie, and based on the keywords and everything, it gives the output as whether this movie is a rom-com, documentary, adventure, and most of the websites like IMDb and popular websites uses this algorithm, since it is difficult to write for every movie, like whether it's a sci-fi or anything like that. And difference between multi-class and multi-label classification is that multi-class problems are mutually exclusive, whereas multi-label problems, each label represents different classification task. Like horror is a different class or different label, romance is a different label, adventure and documentary, so on and so forth. But the tasks are somehow related. How? Because we can't say these are multi-labeled classification, but somehow they are correlated. Like we can take them as classes, like as we took this binomial as binaries by converting it to zeros and ones. But due to this convention, we use this multi-labeled and multi-class classifications. We can label the classes as well, but still this convention comes into the middle and it tells you have to follow the order, since the computer science scientists mention this as a convention one. Now, regression. The major difference between regression and classification is the kind of input we give, because here in regression it deals with the continuous input and gives the continuous output. Continuous input in the sense, let me think, let us assume you're giving an input of weight. So giving data of weight would be different. Like if one of the person have 69.1 kgs of weight, the other one would have 69.2 kgs. So it goes on, it continues from 0.1 to 100, more than 100. If someone is more than obese weight. So here this regression comes, and since classification can't handle this input continuous input data, and we take this out example of house price prediction, which I aforementioned. And here we do the same thing, like we draw the graph, like we use this NumPy or pandas and other things to input the data, which you will learn if you go further in this machine learning field. And you draw a graph and it points some data, like the input data you given, and it draws a straight line to fit the data in a perfect one. So after fitting this data, it starts predicting when you give the next input. Like it is not only useful for house price prediction, it can also be used as stock price prediction. Like you feed the machine with the past stocks of the company, and if you give this new input, like somewhere you want to find what would be the stock price after this 1 month, then if you give this input, it starts analyzing whole data, and it gives the output, not an accurate one. In order to make it accurate, we have to delve deep into this topic, but it uses this thing and it predicts the stock price. And this further linear regression also has been classified into 3 parts, like simple linear regression, logistic regression, and polynomial regression. Simple linear regression was the one I talked about, like house price prediction and stock price prediction, and we don't do it, doesn't do anything. It just fit a simple straight line on the data so that it fits all the data perfectly. Like it covers most of the data. Even though 1 or 2 are left, we can do, we can manipulate this data, but mostly it fits, and it's useful for predicting these house and stock price predictions and so on, so forth, etc. Logistic regression. Here comes a sigmoid function, which we're not going to delve deeper because we have time constraints to wrap up this session as soon as possible. So it is similar to linear regression, and the only difference between linear regression and logistic regression is the kind of line that fits the data. Like unlike linear regression, here the line fits in a S shape. Why? Because we use sigmoid function in order to manipulate or make the line fit in a S-shaped figure so that the output would be categorical. Like it only gives the output between 0 and 1. Like as you can see, sigma of z on the y-axis, it has only two values, either 0, 1 or 0.5. And here we're going to do one thing, like it is kind of similar to this linear or classification problem, but since we are using sigmoid function, it is classified into this regression part. We can even call logistic regression a classification regression as well. Here when we predict the output and it's near to 0.4 or something, it's predicted as 0 and it gives the output as 0. And the same way, if the output is somewhere between 0.5 and 1, it approximates its value and it outputs as 1. And it's the same thing. It is same, but the only thing, as I mentioned earlier, the sigmoid function is being used here. We add bias as well. Bias is nothing but we add extra value to make this output more accurate. And we're going to delve deeper, if we further proceed into this topic or this subject, machine learning. Polynomial regression. Think of it this way, like if you take this example of regression, you fitted the data, but not in a perfect way. Like you just used a simple linear line to fit the data. But in order to be accurate, in order to get an accuracy of 99 or 90 above, think of it, if you get a 90% accuracy, then your prediction would be kind of accurate or near to accurate. So here comes the polynomial regression. Instead of using a linear regression algorithm, we add some quadratic or polynomial functions to this algorithm, and the line fits in this way. Instead of fitting in this way, we added here the polynomial equation, and the line started fitting the data in a curved manner so that it would cover all the points or all the dots in this algorithm, or the input data. This is where it's worked, and mostly we don't use regularly because fitting a simple linear line would be worked mostly. But in difficult situations, or if you have data, a plethora of data, and if you want to cover all the dots, then this polynomial model is used. Coming to the unsupervised learning. Unsupervised learning, as its name suggests, it is done under no supervision. There will be no one to monitor, and this machine learning algorithm does its thing on its own way. And here we are not going to give any labeled data. And I mentioned earlier that to remember this labeled data meaning. Labeled data is nothing but if you are giving a data and if you give a name to its data, like take this example, we are giving this price, or we are giving this data as price, like y-axis data, and x-axis data as size in feet. And if you don't give any labels to it, and if you just drop this, like dropping some dust or some trash into this trash can, in the same way, if you dump this input kind of input to the machine learning algorithm, it learns somehow and it finds this similarity and it clusters the data. Example, if you give this 1,000 photos of cats and dogs, it analyzes data. It analyzes each and every photo that it has, and it finds the similarity of these photos, like it reads in binary way, and it finds some similarity. I don't know how, no one knows how, because they are just they are in binaries, zeros and one, and it clusters the data like cats and dogs, as you can see on the picture. This is what unsupervised learning is. And proceeding further, we have clustering, which is an algorithm in unsupervised learning. Clustering is nothing but the example that I mentioned earlier. Like if you give data, a mixed data, which has the stars, squares, or circles, then it clusters three data and it makes three different clusters in the graph, so that you could use it all in a different ways instead of using the data, a mixed data. Association, it comes after this clustering, and it's mostly used by marketing analysis. And as you if you can see these supermarkets, or a, a big grocery stores or produce farms, they use this marketing analysis. Like they analyze data, or millions of data from people, and what they buy, what they eat, and what they are looking for when they enter the shop. And they predict that whether if a person buys, or if a person X buys this bread, he is going to buy this jam or butter or some other thing which they can eat with this bread. So this is where association works, and it mostly associates or correlates this similarity between the products, and it predicts whether he's going to eat this or not. Like this decisions could be erratic, but it mostly used to in this mass population to predict whether this mass population is going to take this or this, so that they could buy these products and to sell to them. Reinforced learning, which is another self-learning algorithm. It is also kind of unsupervised learning, but here there won't be nothing. Think of an example like chess. So you give these rules, and this what this algorithm does, it goes further. Like it takes one step forward and it checks. There'll be two cases in this reinforced learning. One is reward points, and another one is penalizing. It takes one step forward and it checks whether it's a penalizing step or a reward winning step. And if it's a reward winning step, it goes further. It goes further until it explores all the chart, so that it makes it decision. Like after analyzing this whole thing, it finds out which move would be the best, and it takes the same step when playing with this other human, so that it could win, thinking that if the other person is kind of naive person. But mostly reinforced learning works this way. And if it has this negative feedback, it won't take this step until unless there is a problem. Like if the other person is playing with this machine is too intelligent, so that he could deceive this machine. So this is what this reinforced learning mostly does. And the real example that we are using today, chess, self-driving cars, etc. Self-driving cars, when it comes to Tesla, they didn't written all the code at once, like millions of pages code. What it does is the machine learns on its way. Like when a person goes in a new way, it analyzes this environment, and it feeds the data, and it sends to this headquarters, and the code is written automatically. And when another core goes in the same direction, it must be familiar with it, since the earlier core has sent the data of this new area. This is how this reinforced learning works. Going further, here's the mathematical representation, or the ones we computer scientists use to prove or solve this machine learning algorithm things. Like it would be basic, because I don't want to delve deeper, bearing that it's a basic class of machine learning. Here we have this training set, which we're going to treat or feed this machine in order to gain some experience of handling this data. And thereafter there's a learning algorithm which we're going to write, so that this training set goes into this algorithm, and it somehow learns everything, and it gives the predicted output y, or we would say hypothesis, because when we say hypothesis, it's not a final decision. It's just a hypothesis that we uh, use it for further analysis. Here H is hypothesis, and xi is used to denote this input variables, and yi also to denotes this testing set. Like when we input the data, we divide this input data into training and testing sets, so that we could know whether this algorithm working correctly or not. This training and testing data sets would be split into 80-20 ratio, like training is 80% and testing is 20%, so that this 20% tells you how efficient your algorithm is. And m is called the number of training sets that you have. This subscript is nothing but iteration we use in Python or any other language. Like I is nothing but 1, 2, 3, so on and so forth. We are going to predict this hypothesis, whether this algorithm predicts this output accurately or not. In order to find its accuracy, we are going to define cost function. We measure this accuracy of the hypothesis which we predicted earlier through this cost function, which is nothing but it is 1 by 2m. M is nothing but number of training examples, and we used the mean is half because for the computational convenience of gradient descent, which you're going to probably learn if you like this machine learning thing in the future. And the mean is half due to this computational convenience, because in this machine learning the scientists use so many convenient terms which they they help these algorithms to not get outside or published outside. What does this cost function takes? It takes the average difference between this training data and testing data and the squared of this difference, so that it would give you this output, like how accurate your hypothesis is. And based on this accuracy, you can think of two ways, like going with this algorithm if your accuracy is better one, or taking backward step, like penalizing yourself for giving feedback, like we do or this machine do in reinforced learning, and you implement in a better way. So this is this basic insight of machine learning. Hope you all liked it, and thank you.